Hello, we're now going to begin a series on I2C peripheral. With the I2C, you need to connect your IMU module. You can see that on my starter kit hardware. So this particular module, you need to have that connected in the right place and also in the right orientation, just like you see on the video. And a green LED should come on the module to indicate that it's working. Okay, so that's for the hardware. You need to have this module connected for this tutorial. Okay, now what I'm going to show you at this first part video is that we're going to set up I2C for the particular GPIO pins, and for I2C normal configuration we will do a slave address check function. We'll do a master transmit and a master receive function. Now, for the GPIO setup, that's relatively straightforward. It's very similar to what we did with SPI, UART, and all the other peripherals that has GPIO pins. Then after that, for the I2C peripheral actual configuration, that's also very logical, the slave select and the transmit function. Now, for the receive function, this is one of the most complex one to write on registers level, because according to the reference manual, there is a different state machine for each remaining length. So if you're receiving an I2C and you're receiving only 1 byte, then the sequence is different than the sequence when you've got length of 2 to receive or length of 3. So therefore that needs to be implemented in some sort of a state machine manner. So for that reason, I'm going to keep the I2C receive function in a separate video. So this video should cover up to the master transmit function. All right. So now let's begin and do the coding. We'll refer to the reference manual on the right time and explain to you the kind of skills you need to learn for I2C programming in register level. All right. So let's begin. Now, as always, the very first thing we need to do on the software is to create a peripheral source and header file for our I2C. So we're going to head to the peripheral directory, and on the includes we will add a new header file, and we're going to call it I2C .h. We'll do the same thing on the source files. So we'll add a source file I2C.c. Okay, now the at first we need to include main.h, and then we need to define a few function prototypes into the I2C header file. So the functions we want to define are there are actually 5 of them. We're going to do the GPIO I2C GPIO configuration. So let's write them one by one. So the first one is going to be I2C GPIO pins configuration. This function can take the following form. We can call it I2C as an I2C1. So it might be a good idea for me to show you the starter kit reference manual at this point. This is the starter kit reference or user manual rather, and for the MPU 6050 module, this IMU hardware module, a serial clock is connected to PB8, data to PB9, and an interrupt is on PB12. I don't think we're going to use interrupt at all, but it's there in case you wanted to use the starter kit for another application and you want to test your interrupt skills, you can do that. Alright, so that's going to be PB8 and PB9, and according to the reference manual, those are I2C1. Let me show you where you can find that out. That will be on the I2C alternate function remapping, section 9.3.9. And you can clearly see that I2C1 you alternatively can find out in an I2C section or in the actual pinouts, but this particular one, I2C1, has got a remapping, and therefore PB8 and PB9 are on I2C1. Okay, we're going to refer to this later as well for some purpose. But yeah, so that's going to be I2C1, and that will be GPIO configuration. So I'll say GPIO config, and that takes no parameters and returns none, so that's going to be void in either directions. And the second function, prototype, would be I2C peripheral configuration this time. So that this is the actual I2C registers configuration. All right, excellent. And the third function, now we're going to start adding the API functions, and the third function is going to be I2C check address or scan for address. So what this does is that you give it an address and it will find out if it exists on the I2C bus or not. So it will wait for an acknowledgement from that device. This is very useful. If you have ever used I2C HAL library before, this is similar to is device ready function. All right, and this will take this returns a boolean. So when the slave address exists, it will return 1. So the function would take the following naming. It would be is slave address exist, and we need to pass a parameter, which is the address number that we want to scan for. In our case, the MPU 6050, we know what's the slave address going to be. Therefore, we're going to check for it at the very beginning of the program if it exists on the network or it's currently disconnected or something wrong with the hardware. Okay, so this is the function to check a specific address on the I2C network. Now, the fourth function is going to be I2C transmit. So we really got to there. So I2C transmit and receive. So that's I2C transmit, and we'll be doing the I2C master mode only at this training. Okay, we're not going to do any slave at the moment. So this function will return a boolean if the transmit operation is successful, and we're going to call it I2C1, same naming convention, and that will be master transmit. And the parameter for this includes address, so the I2C address, and then the data we want to transmit over I2C, that will be a pointer to data. And the length of data, so how many bytes we want to send, and finally we need a timeout to define the maximum waiting time. All right, and that's it. Now for the receive function, it's pretty much very similar in parameters. So that will be I2C receive, and that's master mode again. So it would be exactly similar parameter to the transmit function, except data are going to be out, not data input. So I'll copy and paste the same function and change receive with change transmit with receive. Okay. Now we're only going to define the receive function prototype at this particular video, but in the next video it will be fully dedicated for writing the receive function, because that's very, very long. Okay. So it's not really scary or anything. It's not impossible. It's just there are specific cases we need to meet from the reference manual in order to have the I2C receive function correctly. You'll get to see that when you finish it at the end. You'll find it very easy, but at the very beginning it might sound very hard. But yeah, it is achievable. We will do it together, and we'll have it working at the end. All right, so now let's go to the I2C source file, and we're first going to add the I2C header file in here, and then define the function and do the function definitions in here. Okay, now the first is the I2C GPIO config, and from the user manual of the starter kit, we know that it's going to be PP8 and PP9 for I2C1. Let me keep a note of them. So we're going to do PP8 and PP9. 8 being the 8 being the clock, so that'll be the serial clock, and PP9 being the serial data. All right, excellent. Now on here, since both are in port B, we need to enable clock of port B and do some magical stuff. But as always, I first always like to do the alternate mapping. And to check for that, we need to go to the I2C alternate function remapping and find out whether this I2C requires remapping or not. And in a matter of fact, it does, because with the default map, it's BB6 and BB7 who are connected to I2C1. But in our case, we want BB8 and 9 rather, and therefore we need to apply some mapping. And that's done in the alternate IO map register. So let's go there, and we need to look for I2C1 remap. And so we need to do this I2C1 remap. We need to have this bit set high in order to enable BB8 and BB9 as I2C1 pins. Okay, so we're going to do that, and it's going to be very similar to what we did before. It always starts with we enable the AFIO clock. So let's find that in the GPIO.c. We've done it many times. I think in either GPIO. Yep. So I think this particular one, this is to enable the AFIO clock. I'm going to copy that statement to save some time. And then we need to write that remap in high. So that will be the AFIO register. And we need to do map R, but yeah, let's do save. Okay. Map R. And we want to set some bit field high. Okay, so that'll be our I2C 1 remap. And that's it. This is the mapping. Now, this would ensure our pins are mapped to I2C1. Okay, now we need to enable a port P clock, and we can find that out in, I can just actually use the same statement for port A and then replace it with port B in here. It's the same one, and they both use the same register. All right, excellent. And then for a serial clock, the settings we need to do for mode, that needs to be output, and with a speed 10 megahertz. So that would be output, perhaps 10 megahertz, like medium speed. And for configuration, that needs to be alternate function with open drain configuration this time, because that's an I2C, and it's known that I2C is usually open. It's an open drain interface. Okay, if you don't know this, you can read more about I2C and learn how it's physically connected and wired. But yeah, in the GPIO configuration, it needs to be output mode with an open drain output type. Okay, so in order to do this, it's going to be, since those are BB8 and 9, that will be the configuration register high. So that will be the CRH GPIO register. And in order to have the mode set to output with max speed of 10 megahertz, we first need to reset those bit fields for pins 8 and 9, and then have them set to 1, 0, 1 being bit field number 0. Okay, so we're going to do that. So this is GPIO-B, and the register is CRH, and we're going to reset some bit fields at the beginning, and those bit fields are the mode for pin number 8, and also for pin number 9. Excellent. And now we need to set the mode for both of them. Now we need to set some bit field, and the bit field we want to set is bit number 0 in order to enable this particular output mode with 10 megahertz. Okay, so that will be bit number 0 needs to be high. And same thing for mode 9. All right, very good. Now for the configuration, it would be we would like to have the mode to be alternate function open drain, and therefore the 2 bits need to be set high, and that's very easy. We can do that. This is a matter of fact easier than the top one, because all we have to do is to set those bit field high, and we can do that by doing CNF 8 and then CNF 9. It will set both If we didn't specify which bit field, then it was going to set both of them. Okay, and that's what we need. So that's it. This is how we do it. Now the output type should be alternate function and open drain for pins 8 and 9 of port B. Okay, so this is it. This is how we configure GPIO for I2C. All right. Now let's do the I2C peripheral configuration. Now for the I2C peripheral configuration, this is relatively straightforward. There's almost nothing, not much really into it, because I2C peripheral configuration hasn't got much parameters. Now, let me first list all the logical steps that we need to carry out. Now, first we need to enable I2C clock, and then we need to set. There's something that I2C need to know about. It needs to know the APP. It needs to know the actual clock frequency. Remember when we did the RCC setup? So if you look back at the RCC clock, we've got APP1, we've got the peripheral clock, and we've got the timers clock. And I know that I2C is clocked by this particular clock, and its frequency for peripherals like I2C is 36 megahertz. And I2C needs to know that, okay? So we need to tell I2C register about the APP1 clock frequency, so that it does its own calculation to get me the correct I2C clock frequency. So that's another step we need to do. And then we need to set something related to the something called rise time, which is something that helps in setting up the I2C clock frequency. And then we finally need to set the speed. So this is I2C speed, and that's usually 100 kilohertz. And finally is to enable I2C peripheral. So this is to enable the peripheral so that it takes action. All right, now in order to enable I2C clock, let's go and find out. I already told you that it's going to be APP1, and yeah, so we're going to go there, look for APP1 ENR register. Here's the one, and it's I2C1 that we're looking for to enable. So let's do that. That's going to be RCC. And we're going to set some bit field, and that's going to be, and that should be I2C1. All right, excellent. Now, for I2C registers, let's look at the I2C section in the reference manual. Okay, let's look for it. It should be down there near SPI, perhaps. Yep. Exactly, right after SPI, it's section 26, and we'll look for I2C registers. For control register number 1, it has software reset, alert, packet error checking, the position, acknowledgement enable, stop generation. That's pretty much, we're going to use a lot of control register number 1 into when we do the transmit and receive function, but at the moment in the configuration, we might only use it to enable the peripheral. So let's move into control register number 2. All right, this has the DMA enable thing. It has the peripheral clock frequency. That's brilliant. This is one of the things that we like, that we want. Okay, so we're going to use this in one of our steps, and we also want to use, yeah. So actually, looking at the other registers, there are the on address, the data register, the status register, and something related to, let's actually expand them in here so that we can see them better. We have all these, we have the T-rise time, and that's something we're going to use too. Okay, now first of all, we're looking for the first step, and that's to tell I2C about the APP clock frequency. And we saw this in control register number 2. This is the frequency bit fields. Now let's take a look at them and see how that's set up. Okay, so the way this works is that you can set that from 2 to 50 megahertz. Okay, and that's about this binary number. So that's according to the binary. So this is 32 plus 16 and then plus 2, and that will give us 50 megahertz. So all we need is to write the number in megahertz in this particular bit field. So let's do that. We know that our APP clock is 36 megahertz for APP1. That's from the I2C configuration we done in the very first videos. So that's the one. That will be I2C1, and that's in control register number 2. We're first going to clear those bit fields so in order to allow us to set them freely. So we're going to say I2C CR2 and then frequency. So we're going to clear all the frequency bit fields in this case, and then we're going to set only the necessary ones. So that will be, now we're going to set some bit field, and we know this one starts from 0, and that's really easy, which means all we need is to write 36, and that's shifted by 0, which is the same as just writing 36. But I like to write it so that it signifies a starter bit. Alright, brilliant. So that's it. This is how we set the clock frequency. Now after that we need to set the rise time, okay? And this rise time is according to the manual. Let's take a look in there and try to find out about rise time and how to set it up. Should be somewhere explains about rise time. Try to find that. That should be somewhere in here. Alright, yeah, I told you I2C peripheral is rather lengthy in its setup, but it's pretty easy to use later on. Okay, so let's take a look at the rise register. Maximum rise time in frequency mode is SM mode, which is that's in nanoseconds. Alright, so what this one determines the maximum allowed rise time, okay? And here's an example of an ideal setup. If your frequency is 8 megahertz, then the maximum rise time should be 8 plus 1. This is a valid setting. So one of the easy things I can do is that I can use the default recommended options and settings for rise time and have that set to my 36 megahertz plus 1. So that will be as simple as me doing I2C1 T-rise register and write that equal to 36 plus 1. It really is the recommended option, and there is more explanation into it and why that's important. You can read about that, but this is kind of the ideal setting for it. Alright, now the other one is to set the I2C speed, and I want to have that I2C clock frequency, and I want to have that as 100 kilohertz. Now let's take a look at the one of the, I think it's the clock control register, and those are the bit fields. And according to this clock control register, in order to achieve the necessary required clock, there are some calculation here to generate 100 kilohertz frequency. If the frequency register is 8 and the so CCR must be programmed to be 28, which is in a sense